Hello, this is Dr. Baxley, and I'm here to help you with conversions, a really important skill for this class and all your other science and math classes. So this video will give you some tips, and then we'll work through a couple of sample problems. First tip, make sure you start with a measured value and not a ratio if possible. We can look at the sample problem down below, and we can see that we're given some information. We're given information that propane has a density of 0.493 grams per cubic centimeter. That's a ratio, not a good place to start. The question asks us to calculate the mass of a certain volume of propane. That volume is a measured value. That's where we should start. The next step is to gather some needed conversion factors. You might need to look at a table. For example, table 1.2 or 1.3 in the text. For example, we might need to know that a liter is equivalent to 1,000 centimeters. Or we might need one of the metric system prefix multipliers. For example, we'd need to know that 1 kilogram is equal to 1,000 grams. Next tip is to write slash fractions like g/ml as numerator-denominator fractions like this. Just this one simple trick of writing fractions this way rather than as the easy-to-type slash fraction can really help students get to work on a problem much more quickly and get the correct answer. Last tip, make sure that all your units cancel. I'll show you that as an example as we work through the sample problems. All right, let's take a look at our sample problem. Again, we're given the density of liquid propane at 25 Celsius, and we're asked to calculate the mass of a certain volume of propane. Since we're starting with the measured value, 250.0 centimeters cubed, we'll do that. Always make sure you include the units, like the centimeters cubed, to make sure that we know what we're talking about. We can then multiply it by the density that we can use as a conversion factor. We can make sure that centimeters cubed are in the denominator, and the 0.493 grams is in the numerator. We can see that the units will cancel out. Centimeters cubed and centimeters cubed reduce to 1, and they cancel out. And we can then calculate the answer to be 123 grams of propane. I always like to include the name of the substance or some other information just so it helps me remember what I've done and what this number of the answer means. All right, this one, part B, is a little bit more complicated. This asks for the volume in liters of a certain amount of propane, the 2.40 kilograms. Again, we can start with the measured value. That would be the mass of the propane, 2.40 kilograms. In this case, we know the density in terms of grams per cubic centimeter. So I need to convert kilograms to grams using the metric prefixes that we talked about before. 1 kilogram is equal to 1,000 grams. We can use that as a ratio. 1 kilogram for every 1,000 grams, just like that. Now we can use the density as another conversion factor to determine if we had a mass in grams, how many cubic centimeters it would be. We can use the 0.493 grams in the denominator and 1 cubic centimeter in the numerator. Now we need to convert the cubic centimeters to liters. Again, we can go back to this table, and I've already highlighted that 1 liter is equal to 1,000 cubic centimeters. That's a conversion factor you really should know. We can calculate the answer. In this case, it's 4.87 liters of propane. So there's a nice little introduction to converting units the easy way.